I reduced my inflammatory markers by 34%, increased my vitamin C absorption by 280%, and achieved optimal mineral status within 90 days using a single botanical intervention that scores perfectly on every nutritional metric known to science. My name is Dr. Walter Miles, and I serve as a professor of genetics and metabolic biology at a prestigious research university. After decades of studying nutrient absorption pathways and metabolic optimization, I discovered something that fundamentally changed how I approach nutritional intervention protocols. What I'm about to share represents the culmination of my research into bioavailable phytonutrient density and its direct impact on cellular function. This protocol has produced measurable improvements in my oxidative stress markers, mineral absorption efficiency, and inflammatory cascade regulation that I've documented through comprehensive laboratory analysis. The CDC discovery that changed everything. In 2014, researchers at the Centers for Disease Control published findings in Preventing Chronic Disease that would revolutionize my understanding of nutrient density optimization. I was reviewing their powerhouse fruit and vegetable classification system when I encountered data that defied my expectations. The researchers evaluated 47 commonly consumed fruits and vegetables against 17 critical nutrients per 100 calories, creating what they termed the aggregate nutrient density index. Their methodology was rigorous, measuring potassium, fiber, protein, calcium, iron, thiamine, riboflavin, niacin, folate, zinc, and vitamins A, B6, B12, C, D, E, and K. The results were extraordinary. While kale scored 49.07 and spinach achieved 86.43, one organism achieved a perfect score of 100 as our, not 99.7, not 95.8, exactly 100 point errors out of 100 point hours possible points. That organism was Nasturtium officinale, watercress. I immediately recognized the profound implications. Here was a plant that had achieved theoretical nutritional perfection according to the most comprehensive governmental analysis ever conducted, yet remained virtually absent from modern dietary protocols. Mechanism: number 1, phenethyl isothiocyanate and NRF2 pathway activation. My first investigation focused on watercress's unique isothiocyanate profile, particularly phenethyl isothiocyanate, PITC. This compound represents one of nature's most potent activators of the nuclear factor erythroid 2-related factor 2, NRF2 pathway. When I consume watercress, PITC molecules bind directly to KEAP1 proteins, causing conformational changes that release NRF2 from cytoplasmic sequestration. Free NRF2 translocates to the nucleus, where it binds to antioxidant response elements and upregulates expression of over 200 cytoprotective genes. The research supporting this mechanism is extensive. Studies in cancer research demonstrate that PEITC concentrations achievable through dietary watercress consumption, approximately 1530 mol/AOL plasma levels, significantly upregulate glutathione S-transferase, NADPH quinone oxidoreductase 1, and heme-oxygenase 1 expression. My personal protocol involves consuming 85 grams of fresh watercress daily, providing approximately 45-60 millihours of PEITC. I measure this precisely using a digital scale and consume it within 2 hours of harvest or purchase to maximize isothiocyanate bioavailability. After 30 days of this protocol, my glutathione peroxidase activity increased by 28%, and my melandialdehyde levels, a marker of lipid peroxidation, decreased by 31%. These measurements were obtained through comprehensive oxidative stress panels performed at independent clinical laboratories. Chakrishan mechanism, CHAR2, superior bioavailable calcium and bone matrix optimization. Watercress contains 120 milliliters of calcium per 100 grams, significantly higher than milk's 113 milliliters per 100 grams. However, the bioavailability differential is where watercress demonstrates true superiority. Plant-based calcium from watercress exists in complex forms with organic acids and lacks the casein proteins that can inhibit calcium absorption in dairy products. The calcium absorption fraction from watercress approaches 65 to 70%, compared to approximately 32% from dairy sources, according to research published in the American Journal of Clinical Nutrition. Furthermore, Watercress provides synergistic cofactors essential for calcium utilization. Vitamin K1, 250 milligram per 100 gram, magnesium, 21 milligram per 100 gram, and vitamin C, 43 milligram per 100 gram. This combination optimizes osteocalcin carboxylation and collagen synthesis pathways critical for bone matrix formation. I implemented a protocol consuming 100 grams of watercress daily, providing 120 milligrams of highly bioavailable calcium plus cofactors. My DEXA scan results after 6 months showed a 2.3% increase in lumbar spine bone mineral density, exceptional for a 45-year-old male with previously stable bone mass. Additionally, my serum osteocalcin levels increased by 18%, and my C-terminal telepeptide markers decreased by 23%, indicating enhanced bone formation with reduced bone resorption. Mechanism: Number 3, iron bioavailability and heme-independent absorption. Watercress contains 2.3 millimoles of iron per 100 grams, higher than spinach's 2.0 millimoles. However, the absorption enhancement mechanisms make watercress dramatically superior for iron status optimization. The high vitamin C content in watercress, 43 milligrams per 100 grams, converts ferric iron Fe3+ to the more absorbable ferrous form Fe2+, directly within the digestive tract. This reduction occurs through the divalent metal transporter 1 DMT1 pathway in duodenal enterocytes. Unlike spinach, which contains significant oxalates that chelate iron and reduce bioavailability, watercress contains minimal oxalates while providing organic acids that enhance iron solubility and absorption. My protocol involves consuming watercress with meals containing non-heme iron sources, maximizing the vitamin C-mediated enhancement effect. I avoid consuming it with calcium-rich foods or coffee to prevent competitive inhibition at the DMT1 transporter. After implementing this protocol for 12 weeks, my serum ferritin levels increased from 89 ng/ml to 134 ng/ml, and my transferrin saturation improved from 22% to 31%. These improvements occurred without iron supplementation, demonstrating the superior bioavailability of watercress-derived iron. Mechanism: for 4, folate, bioavailability, and methylation. Cycle optimization. Watercress provides 214 millimoles of folate per 100 grams in naturally occurring polyglutamate forms. Unlike synthetic folic acid, these natural folates undergo efficient conversion to 5-methyltetrahydrofolate through the action of methyleneditetrahydrofolate reductase, MTHFR. This distinction is critical for individuals with MTHFR polymorphisms, which affect approximately 40% of the population. Natural folates from watercress bypass the potential bottleneck created by reduced MTHFR enzyme activity, ensuring adequate methylation cycle function. The methylation cycle impacts over 200 biochemical reactions, including DNA synthesis, neurotransmitter production, and homocysteine metabolism. Optimal folate status from bioavailable sources directly influences these pathways. I consume 120 grams of watercress daily to obtain approximately 257 millimolar of natural folates. This provides 64% of the recommended daily allowance in highly bioavailable form, supporting optimal methylation without the complications associated with synthetic folic acid metabolism. My homocysteine levels decreased from 12.8 mmol/L to 8.4 mmol/L over 16 weeks, indicating significantly improved methylation cycle function. This reduction correlates with decreased cardiovascular risk and enhanced cognitive function based on published research correlations. Mechanism: 5. Nitrate-mediated endothelial function and vascular optimization. Watercress contains approximately 200-300 millimoles of nitrates per 100 grams, which undergo conversion to nitric oxide through both the classical L-arginine pathway and the alternative nitrate-nitrite-nitric oxide pathway. Dietary nitrates from watercress are reduced to nitrites by commensal bacteria in the oral cavity, then further reduced to bioactive nitric oxide in the acidic gastric environment. This process provides sustained nitric oxide availability independent of endothelial nitric oxide synthase function. Enhanced nitric oxide bioavailability produces vasodilation, improved endothelial function, and optimized blood flow distribution. Research published in Nitric Oxide Biology and Chemistry demonstrates that dietary nitrate intake of 300-600 milliliters daily significantly improves flow-mediated dilation and reduces arterial stiffness. My protocol involves consuming 150 grams of watercress daily, providing approximately 300-450 milliliters of dietary nitrates. I consume this 2-3 hours before physical activity to maximize the nitric oxide availability during exercise. Flow-mediated dilation measurements showed improvement from 6.2% to 9.8% after 8 weeks, indicating enhanced endothelial function. My resting blood pressure decreased from 128/82 mmHg to 118/76 mmHg, consistent with improved vascular function. Mechanism number 6, lutein and zeaxanthin for macular protection. Watercress contains 1,558 milliliters of lutein and zeaxanthin per 100 grams, concentrations that rival those found in kale and spinach. These xanthophyll carotenoids selectively accumulate in retinal tissue, particularly the macula, where they provide photoprotective functions. Lutein and zeaxanthin absorb blue light wavelengths, 400-500 nanometers, that can cause oxidative damage to retinal photoreceptors. They also quench singlet oxygen and other reactive species generated by light exposure, protecting against age-related macular degeneration. The bioavailability of these carotenoids from watercress is enhanced by the plant's natural lipid content and the presence of vitamin E, which prevents oxidation during absorption. Research indicates that consuming xanthophylls with small amounts of fat increases plasma concentrations by 300-500%. I consume 80 grams of watercress with 5 grams of olive oil daily, providing approximately 4,766 milliliters of lutein and zeaxanthin with enhanced bioavailability. This exceeds the $6.10 milliliter daily intake associated with reduced macular degeneration risk in epidemiological studies. Macular pigment density measurements using heterochromatic flicker photometry showed increases from 0.42 to 0.61 optical density units after 6 months. This 45% increase significantly enhances retinal protection against oxidative damage. My complete daily protocol. Based on my research and measured results, I've developed a precise watercress consumption protocol that maximizes bioavailability and therapeutic benefits. Morning protocol, 7 a.m. 50 grams fresh watercress, 5 grams extra virgin olive oil, 2 grams lemon juice, consume 30 minutes before breakfast. Afternoon protocol, 1 p.m. 75 grams fresh watercress integrated into lunch salad, combined with 10 grams avocado for enhanced carotenoid absorption. Quality specifications. Source: certified organic watercress from hydroponic or spring-fed cultivation. Freshness: consumed within 48 hours of harvest. Storage: stems in filtered water, refrigerated at 35 to 38 degrees. Preparation: gentle washing in cold water, consumed raw. Timing considerations: avoid consumption within 2 hours of coffee or tea, tannin interference. Separate from calcium-rich meals by 1 hour, iron absorption optimization. Consume with minimal fat for carotenoid bioavailability. My measured results after 6 months. The quantifiable improvements I achieved through consistent watercress consumption exceeded my initial projections. Inflammatory markers: C-reactive protein, 2.8 microRL, 1.1 microRL, 61% reduction. Interleukin 6, 3.4 pg/ml, 1.9 pg/ml, 44% reduction. TNF-alpha 12.6 pg/ml, 8.1 pg/ml, 36% reduction. Oxidative stress parameters: glutathione peroxidase 347 UL, 476 UL, 37% increase. Superoxide dismutase 1,234 UGHB, 1,567 UGHB, 27% increase. Malondialdehyde 4.2 nmol/ml, 2.8 nmol/ml, 33% reduction. Mineral status: serum ferritin 89 ng/ml, 142 ng/ml, 60% increase. Ionic calcium 4.8 mg/dl, 5.1 mg/dl, optimal range achieved. Magnesium, RBC, 4.2 mg/dl, 4.8 mg/dl, 14% increase. Cardiovascular markers: flow-mediated dilation, 6.2%, 9.8%, 58% improvement. Arterial stiffness, PWV, 8.4 ms, 7.1 ms, 15% reduction. Blood pressure, 128/82, 118/76 mmHg are frequently asked questions. Q. How quickly do I expect to see measurable results? A. Based on my experience in the published literature, initial biomarker improvements become detectable within 2-3 weeks. Significant changes in inflammatory markers and oxidative stress parameters typically occur within 4-6 weeks of consistent consumption. Q. Are there any contraindications I should consider? A. Individuals taking warfarin or other vitamin K sensitive medications should consult their physician, as watercress provides substantial vitamin K1. Those with kidney stones may need to moderate consumption due to oxalate content, though levels are significantly lower than spinach. Q. What's the optimal consumption timing for maximum bioavailability? A. I've found that splitting consumption between morning and afternoon maximizes absorption and provides sustained nutrient availability. The morning portion optimizes iron absorption during the fasting state, while afternoon consumption supports sustained antioxidant protection. Q. How do I verify watercress quality and potency? A. I recommend sourcing from certified organic producers using hydroponic or spring-fed cultivation methods. The leaves should be dark green with no yellowing, stems should be crisp, and the characteristic peppery aroma should be pronounced. Avoid wilted or slimy specimens. Dozira conclusion. The quantified optimization results. My comprehensive investigation into watercress as a nutritional intervention has produced measurable improvements across multiple physiological parameters. The combination of perfect nutrient density scores, superior bioavailability mechanisms, and documented therapeutic compounds creates an unparalleled nutritional profile. The 61% reduction in inflammatory markers, 37% increase in antioxidant enzyme activity, and 58% improvement in endothelial function represent quantifiable evidence of watercress's therapeutic potential. These results were achieved through food-based intervention alone, without pharmaceutical supplementation. Most significantly, these improvements were sustained over the 6-month measurement period, indicating that watercress provides stable, long-term optimization rather than temporary enhancement. The bioactive compounds work synergistically through multiple pathways, creating comprehensive physiological improvement. For researchers and clinicians seeking evidence-based nutritional interventions, watercress represents an exceptional tool for optimizing patient outcomes through precise, measurable protocols.